In this video, we will see some applications of implicit differentiation for problems related with business and economics. So the problem we will be working in this case is related with the elasticity of demand. So if this is my expression for the demand for Q units when the price is P, then the elasticity of the demand is this expression here. We will break this expression down in a bit, but let's see how we can understand this situation. So the idea of the elasticity is that if we increase the price P, and the first case is the quantity demanded does not change too much, we say that this situation is the demand is inelastic. On the other hand, if the quantity demanded changes a lot, we say that this situation is, in this situation, the demand is elastic. So to measure when the demand is inelastic or elastic, we will use this formula here. So let's work an example. So we want to find the elasticity of the demand function. This is our function, P plus 10Q is equal to 100 in two cases, when the price is $60 and when the price is $20. So let's see how to solve this problem. First, let's start remembering the formula for the elasticity. It was minus P divided by Q times the derivative of Q with respect to P evaluated at the given point. So probably the best way to start this problem is try to find this derivative that is involved in this problem. So how do we do that? Well, we use implicit differentiation on our equation. So we have that the equation involved is this, P plus 10Q equals 100. So we can use implicit differentiation with respect to P, and we will get the following. The derivative of P with respect to P is just 1. Then we will get 10 times the derivative of Q with respect to P equals 0. So from this, solving this problem, we get that the derivative of Q with respect to P is equal to negative 1/10. So now we have the derivative, and notice that the derivative is constant. It doesn't depend on the point we're evaluating it. So we don't need to worry about this. We will see some examples in class where we have to change the point. So the only thing remaining is to find P and Q for each case. So if P is equal to 60, that is my first case here. So if P is equal to 60, then the quantity it's equal to 4 by plugging it in our equation. So this gives me that the elasticity in this case is minus 60 divided by 4 times negative 1/10, which is equal to 15 divided by 10, which is 3/2. The second case, we have that the price is equal to 20, so the quantity it's equal to 8. So in this case, the elasticity it's equal to negative 20 divided by 8 times negative 1/10, which is equal to 1/4. When the elasticity of demand is greater than 1, so in this case this is greater than 1, we say that the demand is elastic. When the demand is less than 1, we say that the demand is inelastic. We will see more details about this in class, but essentially if the elasticity is greater than 1, we say that the demand is elastic, and when the elasticity is less than 1, we say that the demand is inelastic.